my head,
Okay.
So I might need you to share with me your notes and what you learned in class so that I can
Yeah.
explain it and help you do it. All right, so find the area under the standard normal distribution curve between z equals 0 and z equals negative 7.8. So this is called z-score, right?
Yeah.
And remind me what your teacher talked about or what you've learned about z-score so far.
You just, I don't know, you just kind of like make a little graph there, and then like there's like a number that's like always in the, like there's 68th percentile, 95th percentile, and like 99th percentile. Like you divide up the distribution into that, something like that.
Okay, do you have a formula for z-score,
No.
or do you use like a z-score calculator for it or something?
We usually just get it.
Okay, so they're saying find the area under the standard normal distribution curve. I feel like for what I remember with this is there's some sort of table that you look at, or maybe there's nowadays it's in a calculator and you just plug it in. Like if your z-score, for example, what does the z-score of 1 mean?
Not sure.
Do you have notes about that?
Um, yeah, but how would can I screen share?
Yeah, you can screen share if you have it digitally.
Yeah. It says I can't share when you are.
Oh, okay. All right, let me unshare mine. Let's see, how do I unshare mine? Okay.
Can you see this?
Yeah. Find the area underneath the section of the normal curve. Okay, so u is the mean, right? That Greek u
Yeah.
is the mean, and that one that looks like a fancy 0 or a fancy O is the standard deviation.
Mm-hmm.
So you start at the mean. Your z-score would be your observed value minus the mean of the sample, and you divide it by the standard deviation. So like a z-score of 1 basically means that it is 1 standard deviation away from the mean. I believe that's what that means.
Okay.
You understand what I'm saying?
Sorry, did you say z-score of 1 or z-score of 0?
So like,
is that?
Like if you had a z-score of 1, well, you couldn't have a z-score of 0. I don't think that would make sense. A z-score of
Yeah.
A z-score of 0 would basically mean that it's just right. It's the mean. A z-score of 0 would mean that you're perfectly at the mean, the average, like the top of that hill, right? The standard deviation's got that. Those graphs are the standard deviation. But a z-score of 1 would mean it's 1 away. You know how you've got that 34% and the 34% on your normal? That's 1 away. So it would be a z-score of 1 would have 68% of
so it's like 1 section away.
Exactly. That's what z-score means.
Okay.
From what I remember. Like I said, I don't do this very much. I don't have notes on it. I'm just remembering it. I'm kind of looking up on my separate computer. Um, I'm reading some. What does a z-score of 1 mean? Z-score of 1 tells us that the z-score is 1 standard deviation above the mean. Thus, these two scores are the same distance away from the mean, but in opposite directions. So a z-score of, let's see, z-score of 1.5 measures means a value of 1.5 centimeter greater than the mean. Z-scores can be negative if they're below the mean. So for the 3 sigma rule, 68% of the values between. Okay, so actually a z-score, I think I said it wrong. If it's a positive z-score, it's just to the right of that. So it's that 34% to the right of the mean.
Okay, and
So,
then negative,
but
I'm assuming the same.
yes,
Vice versa.
so yes, correct. So the question says find the area underneath the section of the normal curve. Given the area, find the z values on the normal curve. So, all right, can you go to your next page on this example? So this is talking about a normal distribution. See how you've got a bell curve, mean, median, or mode are equal, and at the center, because this is a normal distribution, the total area underneath the curve, okay, there we go, is 1 or 100%. So you're talking about that was what I was looking for. The area under the curve, they're talking about what is the percentage, what's the percentage of population that would be in that particular area. So okay, keep going. Go to the next page. See if we see some examples. Okay, here we go. You always draw the normal. All right, so find the area under the curve of the between z equals 0 and z equals 2.34. So what they're doing is they're using did you see that formula they're plugging in? This is what I was talking about, that table.
Yes,
When
sir.
I taught this, I had to use a table, like in a book, and I had to use the table. But now
Oh, I remember that
in your
from last year.
calculator,
Yeah.
yeah, in your calculator, all you have to do is plug into the normal curve distribution function, NCDF, I believe is what that stands for. And you just type in 0, 2.34, 0, 1. Yeah, does that make sense? How you plug it in? You see those formulas? Here, let me take a picture of this. Go scroll up just a little bit so I can see more problems in the bottom, and then I'll use these to help you understand this. Scroll up a little bit more. Matt, can you scroll up just a little bit more so I can see more on my screen? Other way. I want those example
Oh,
problems. Sorry. Yeah, that right there. Let me see that whole thing.
Yes.
There you go. Perfect. Right there. Let me see how I can take a picture of this. Okay. Okay. So go ahead and give me control back. You can turn off yours.
Okay.
So I took a picture of that so you can see. Now you're gonna have to get your calculator out.
Yeah.
Figure out how to get that formula. Do you know where that formula is at on your calculator?
No, but I'm trying to look right now.
Oh yeah. So if you look at your calculator, it's probably in math, maybe, and maybe number or probability. It's in probability, maybe.
It says on, I just like Googled, it says second and then vars and then it's on the distribution menu and then after that I don't know where to go.
So has your teacher explained this to you in class at all?
I don't think so.
Because I don't know, and the one I'm using right now really. Oh, second vars, so distribution. Okay, so see where it says vars, and then it says distr,
Yeah.
distribution. Yeah, that's where it is. And then you want to go to NCDF, normal CDF. See the second one right there?
Yeah.
So that's what I'm going to type in. And then I'm going to type in the left limit. I'm just going to test it with this one example, number one that you have here. The left limit, comma, the right limit, which is 0, comma, and then you type in 0 and 1 because you want, those are like the parameters I think that you're putting in there or something. I think it's always 0, 1. And that is not the right answer. Oh, it's because it didn't give me, it rounded it or something. I wanted this to be negative 0.78, comma, 0, comma, 0, comma, 1. Yeah. See how that works?
Yeah, I just did it too.
Oh, that's what they want you to do here. So
Okay.
to the right of, and so to the right of 1.39, you would put infinity in there. You understand that? Because you're trying to find what the area under the curve or the percentage under the curve is. So you put in.
On my calculator, it just says lower and upper. It's not. It doesn't say like I just typed in 0 and then or I typed in negative 0.78 and 0 like without parentheses and it gave me 28%.
Okay. Oh, you don't have 4 digits in yours? Is that what you're saying?
No.
Okay. Yours might be different. I'm not sure how you type in infinity. I'm not sure if you can just type in a big number to represent infinity. Let's see if that works. 0, comma, 1. Yeah, that worked. So I don't know if you can't find infinity, just type in like 1,000 or something.
Okay.
And
Yeah.
that should work. Okay.
Yeah.
So what you're doing with this, just to help you understand what's going on here, is you're taking what this formula does for you is it takes, take a look at this picture right here. You're finding the area underneath the curve, like how many of the data points exist between a z-score of 0, which is right here, and a z-score of negative 0.78, which is not quite 1 standard deviation to the left. So that's what you're finding. That's the area that you're finding there with that formula. That makes sense?
Yeah, it does.
So look at this next example, the z-score between that and that. So it's going to be less than you're to the right of the standard deviation. So this is going to be a small percentage. If you think of what your normal distribution normally has, what was it, like 38% or sorry, was it 34%? I forget.
Yeah, it was 34%.
It was 34%. So this is your U right here, your mean, and this should be 34%, and this should be 34%. So if you plug into this equation, if you plug in -1, comma, +1, what amount should you get if you plug in -1, comma, sorry, -1, +1?
68%.
That's right. You should get 68%. Good job. So let's see if that works. And that's what I get. Okay. You understand
Yeah, on the answer key, it says the answer is 4.76.
Yeah, I'm just showing you. I wasn't doing this example. I was just giving you a visual of what the z-score thing does. So for this one, no, I'm going to type in. Now I'm going to type in the problem. This is the problem. 0, comma, 1. 4.76.
Yeah.
Right. You understand that? So that's how problems. So to the right of negative 2.94 or 92 is going to be like 90 something percent. It's going to be most of it, right?
Yeah,
You know,
yeah.
does that make sense?
Mhm.
So if you go negative 2.92 comma and then just put a big number, I'm just choosing 4,000. I don't know why. 0 comma 1, you're going to get 99.8.
Okay, yeah, that makes sense.
Okay, so that's how you
Yeah.
do that. That's what z-score is all about. Okay,
Yep.
so you good with the rest of these? You want me to do the rest of them as well?
I think I'm good with the rest.
All right, do you have other kind of problems that you want to work with, like page 4?
Yeah, I think page 4 is a little different.
Okay, so the average salary for first year teachers is that much. If the distribution is approximately normal with a standard deviation to the theta, what is the probability the randomly selected teacher makes? So we're gonna do it. We're gonna find a z-score for this. Okay, so
Mhm.
to find a z-score, your formula, I believe, is it's your observed value minus your mean divided by the standard deviation. Okay.
Okay.
So
Yeah.
my observed value, the z-score for this one, I'll do that in black, would be 19,864 minus the mean, which is 27,989, divided by the standard deviation, which is 3,250. That's going to be my z-score for that first one that I circled in black. So type in 19,864 minus 27,989 divided by 3,250. Hopefully I typed that in right. So it's negative 2.5. That's your z-score for that black one that I circled. And your z-score for the 29,000 is you change this to 29614. That's the only thing you change. So I'm going to hit second enter to get back that formula, and I'm going to type in here 29614, and it's 0.5.
Okay. Yeah.
Got it. So now go back and grab that normal. Whoops. Go back and grab that normal, whatever that NCDF function, and type in your negative 2.5 to positive 0.5, and then I have to type in 0 and 1. Again, I don't know if you have to do that or even if I have to do that, but it's good to do it. And you'll get the area is, or the probability is 68.53%.
Yep, that's what I got.
That's the right answer?
Yep.
All right, so more than 3,200, we take this 3,200, we put that in here, or sorry, 32,000. Put 32,000 in there. Find out what your z-score is when you put 32,000 in there, and then do your NCDF from whatever that z-score is to infinity, 0 comma 1, and you'll get your answer for that as well.
Okay, sorry. Did you say that the U was mean or was the O
Yeah,
mean?
U is the mean and O is the standard deviation.
Okay.
Because you're figuring out how many standard deviations away it is away from the mean. That's what a z. It's how many standard deviations away it is from the mean.
Okay. Yeah.
Okay.
Yep.
So same with this one, the average price of that computer, there's the average price. So that's your mean. If the computer price is approximately normal distributed, and the standard deviation, so that's your, whatever that letter is called, that Greek letter. I forget, what is it, mu and theta, maybe?
Yes, I think so.
I don't remember what they are, because like I said, it's been a long time since I've taken this. What is the probability the randomly selected PC costs more than 20? So this is your X. So do 1,200 minus 949 divided by 100. That's going to be your z-score. and then plug it into your NCDF, whatever that z-score is, to, it says more than that. So to infinity, 0, 1. And again, instead of infinity, if you want to just plug into large, works too.
Yeah, okay.
Okay. And then this is probably the same kind of thing, right? So the score has the mean. So this is your mean, and this is your standard deviation. Teacher wants to give an A to the top 5% of scores. What is the cutoff? So you kind of actually have to, I don't know how, if I had the table, you'd be able to do this easily, but you're going to have to plug this in. You're trying to find out what X is to where that would be the top 5% of scores. What does the normal distribution say to the right? What's the 5%? What's the z-score to the right? Is it 3? What's the area underneath the curve 3 standard deviations away? Like, what are the numbers? Remind me what the numbers are. It's 34.
34, 68, and then
What's this one here? What's 2 away? This is 1.
I don't remember.
Yeah, I don't either, but so it's going to be somewhere around here. It's going to be like 2 point something, I think.
So
and I don't know how you do it without just kind of guessing and checking and extrapolating it. But you know what I'm saying? You're trying to plug in a number so that when you plug in 76 or X minus 76 over 5 equals, and you want that to be equal to 0.05.
okay, I'll ask him about that tomorrow.
But you need to have this NCDF function in order to do it. So what I'm saying you can do is you can just guess and check it. There might be another way to do it, but let's try 2.3. Let's see if how close that is. 2.3. I'm sorry. Yeah, 2.3. Sorry, I did this wrong. This is the z-score, comma, infinity, comma, 0, comma, 1. And that z-score is found by doing that formula. X minus 76 over 5. You know what I mean? But yeah, I don't think you plug. I don't know how you solve for that other than just try to guess and check. So let's see if we can guess and check it correctly. Comma, 0, comma, 1. Let's see how close we are. If we guess it at 2.3, the z-score is 2.3. So that's 1%. So I gotta go further to the left. So go up and grab this again and get 2.01. Whoops, that didn't work. 2.1 comma 4,000. See if that works. Okay, so we actually needed to be to the left of that. So let's try 1.8. Do you understand what I'm doing here?
Sorry, why? How do we know it needs to be to the left of 0.01?
Because I want this number. Look at that number I'm getting. What do I want that number to be?
Oh, 0.0. Okay.
Yeah, so I'm just continuing to go to the left until I get that number where I need it to be. So let's try 7.7. So that's close. How about 0.8? I'm sorry, 0.6. All right, so it's going to be between 1.6 and 1.7. So maybe 1.65 now. This is called extrapolating.
Yeah, okay.
Extrapolating the data. So let's try 0.65, comma 4,000, comma 0, comma 1. All right, and that's pretty close. So maybe 0.66. So I know that this is going to have to be equal to maybe 1.66 roughly, right? Again, there may be a formulaic way of doing this. Okay, so that should have been 6.7. My bad. So let's try 1.67 and see how close that is. Dang. 1.67. Am I going the wrong way? Oh yeah, I'm going the wrong way. 1.64. I'm going the wrong direction in my extrapolation. All right, that's close enough. So I want this to be equal to, you see how I did that? I know that that has to be equal to 1.64. So now I can solve
so
this.
yeah.
So 1.64 times 5, 1.64 times 5, and then add 76 to that. So 84.5 or 84.2 is the cutoff for an A,
Okay.
approximately. And
Is
again,
that-
there might have been a better way to do that, but I don't know what, because what you see what you're doing, you're trying to solve for something inside this formula, but you can't. I don't know your calculator can handle doing that.
yeah, I'll ask him tomorrow if there's something better than guess and check.
Yeah, there might be. The same thing with this one. You just do the same thing, but on the left end of the spectrum.
Okay.
Sound good?
Yep.
All right. Hopefully that helped. Good luck with this.
Thank you.
See you, bud.